The other thing I want you to pull out is your packet. There is a mathematical models worksheet, and it is after worksheet 1. I think it's page 5. I don't know off the top of my head, but I think it's page 5. Okay, so, yep, page 5. Okay, so this worksheet or this handout is going to be your guide on how to write mathematical models. If you look on your yellow physics helper, you have a yellow version. I have an orange version. But if you look on your yellow physics helper, mathematical models is this whole bottom section right here. And you have access to this in every single testing quiz. I am going to guarantee that for every test we take in class, almost every, you are going to have to create a mathematical model. So I want to make sure that you understand how to write mathematical models well, and the more times we do it, the better you'll get at it. This is one of those skills, along with the CER, where I want you to come out of this class feeling like a mathematical model expert. It's something that is not isolated to science. You use it in almost any industry. Business, you have to collect data, maybe financial data, to see how well your business is doing. You have to make a plan on what you're going to do financially in the future. I'm using this demonstration because my husband is in finance, and he literally creates mathematical models as his career, in his job, for big businesses. If you're in the medical field, you have to look at patterns, see trends, collect data, and interpret the data. So being able to interpret data is important, but being able to develop an actual equation out of that data is super valuable. So this handout is how we came up with the equation to compare circumference versus diameter. So, for example, I have a piece of string, and all I did was measure out the circumference of a round object, collected the length of that in centimeters, and then I measured the diameter. I collected the data for that. I plotted it on a circumference diameter graph, and that gave us the value for pi. This is literally how scientists came up with the value for pi out to a gazillion digits, right? So 3.14 something, they were able to collect tons and tons and tons and tons of data to get the most accurate value for this magical number pi, which we use in so many different scenarios, especially when we're working with spheres and circles. So how did they come up with that? Was through mathematical modeling and graphical analysis. Most of the graphs we're going to come up with are linear, meaning a line. And when you come up with a line, you guys should know that you're going to have an equation that follows the formula of y equals mx plus b. In your graphing tool, they use y equals ax plus b. It's a different notation, but it means exactly the same thing. You guys know m represents the slope and b represents the y-intercept. So here's what a lot of my students want to do. They want to collect data and tell me that the equation is y equals a slope of 3.37 x plus whatever the y-intercept is. Y and x mean nothing to me. Circumference and diameter make sense, okay? So I don't want you to use y and x in all your mathematical models, because all our mathematical models need to be specific to a certain scenario, which in this case is circumference and diameter. When you get into your worksheet, you're going to create mathematical models. Let me switch over. I really don't like this system. But you're going to create mathematical models out of cost and number of downloads. So instead of y and x, you're going to use cost equals whatever your slope is times your downloads plus your y-intercept. Okay, so there's another thing I want to talk about. This is probably the hardest part about the mathematical model. It's also in your physics helper, so you don't have to memorize it, but it's something called the 5% rule. And I'm just going to explain it to you now. This, what's the y-intercept if you just look at it? 0. But if you actually graph it out in detail, and these graphical analysis will give you an accurate value, it's actually negative 0.005. Do you think that negative 0.005 is significant in our mathematical model for this graph?
Yes.
Yes? Here's a way to tell. The way to tell is to compare it to all of your data. If you look at these dots, they're not going to be perfectly on the line. We call this a line of best fit. And your graph program is going to do this much more accurately than you can eyeball it. So these points are not going to be perfectly on the line, which also means that there's going to be some error, and there's also going to be error in your y-intercept. In order to account for that error, we always do something called the 5% rule. It's in your physics helper, and it's also in this. I'm so not used to this computer. Let me pull it up again. It's also in this worksheet here, where in the circumference and diameter scenario, your y-intercept is 0.037. Also really, really close to 0, right? So how can you check if that y-intercept is valid, especially if the graph looks like it crosses the 0 axis? Don't just drop it because you think it should be dropped. You have to use something called the 5% rule. So the 5% rule is to see if your y-intercept, that really small value that looks like it's close to 0, is less than 5% of your maximum y value. In this case, it's my maximum circumference that I was able to calculate. Usually you'll get data, but I would say my maximum circumference here is 20. This is my last data point. So if I compare 0.037 centimeters compared to 20, do you think that's going to be significant, that tiny decimal? Probably not, but we still have to check. So this is how you check. 0.037 is your y-intercept. Always take the absolute value. In your worksheet, you're going to have a negative 0.005. Take the absolute value. And then you divide it by your maximum y, which here it's 20. And if you multiply that division by 100%, you get your percentage value. So 0.185 is really small. If you turn it into a decimal, it's 0.0085185. So 0.185 is obviously less than 5%, and if it's less, you drop it. So your final equation is circumference equals your slope, which was just given to you up here. The slope is A. In your worksheet, it'll tell you slope is this. And then the times your x variable, which is diameter, and then your y-intercept is just dropped. If it's greater than 5%, look at, I'm not going to pull it up, but look at problem number 2. Do you think that y-intercept needs to be dropped? Just by looking at it. Probably not, because it's not even close to 0. Still do the still do the 5% rule to check, But if it's greater than 5%, then keep it and put it into your equation. So one thing I want to point out is a lot of students, when they're doing this, they identify the y-axis variable and the x-axis variable from their x and y-axis. This is your variable. The value in parentheses is your unit. You don't use your unit in your equation. You would never want to say centimeters equals 3.14 centimeters, right? That makes no sense. So always put your variable, which is outside the parentheses, equals your slope times diameter. So a lot of students make that mistake. We are going to grind through this worksheet together. The last part of this worksheet is to do it by hand. So you're going to plot the dots, just like this. I'm just going to do it. I'm not even going to do it right. I'm just going to add a bunch of dots. Let's say that's my set of dots. You're going to draw, using a ruler, a line of best fit that you think goes through the center of those dots as best as you can. I know you can't see that. I actually drew a really, really nice line, and I'm going to attempt to draw over it, but it's definitely going to ruin that perfection. That's a line of best fit. It's eyeballing, so it's not as accurate as your graphing simulation. But when you draw a line of best fit and calculate your slope, always choose points on your line. Don't choose data points that don't actually fit your line of best fit. These don't actually fall on the line, so choose random points that look nice and do your slope calculation. Y2 minus Y1 over X2 minus X1, and that's your slope. Equation is also in your physics helper if you didn't memorize it. Question? Y-intercept. If you don't drop it, then you always put it, again, I'm going to switch back. You always put it at the end. So it's y variable equals slope, that's a number value, times your x variable plus your y-intercept value. So you're just going to add it to the end. Okay, let me have you get into your groups. You have about 20 minutes to get through as much as you can. There's going to be an answer key. Miss, feel free to grab a calculator to calculate your slope. Feel free to grab a ruler if you actually get to the part where you have to write or draw your line of best fit. And if you don't finish for homework. That's your only homework, except for your CER if you didn't turn it in. And Miss Lee posted a video. So make sure you correct it. Remember, I said I want to see red marks on your paper to show me that you corrected your worksheet. The video's long, so if you just want to skip around, then skip around, find your answer, and move on. If you get the answer wrong, rewind it a little and watch the explanation that Miss Lee put together for you.